Hello everyone, welcome back to my channel InfoSec Lab. Today we're going to talk about SQL injection, one of the most common vulnerabilities in web applications. Specifically, we're going to focus on two types of SQL injection, which is second order and out-of-band SQL injections. These are a little bit more advanced techniques that are used by attackers and penetration testers. Okay, so here's a quick recap. We have three types of the SQL injection: the in-band, out-of-band, and inferential. In the in-band SQL injection, this technique is considered the most common and straightforward type of SQL injection attack. In this technique, attackers use the same communication channel for both injection and the retrieval of data. There are two main types of in-band SQL injection: error-based SQL injection. The attacker manipulates the SQL query to produce error messages from the database. These error messages often contain information about the database structure, which can be used to exploit the database further. Union-based SQL injection. Attacker uses the union SQL operator to combine the results of two or more select statements into a single result, thereby retrieving data from the order tables. Inferential SQL injection, or which is also known as supply SQL injection. Inferential SQL injection does not transfer data directly through the web application, making exploiting it more challenging. Instead, the attacker sends payload and observes the application's behavior and response times to infer information about the database. There are two types of inferential SQL injection: Boolean-based injection. The attacker sends an SQL query to the database, forcing the application to return different results based on a true or false condition. By analyzing the application's response, the attacker can infer whether the payload was true or false. Time-based SQL injection. The attacker sends an SQL to the database, which delays the response for a specified time if the condition is true. By measuring the response time, the attacker can infer whether the condition is true or false. Alright, same concepts, different approaches. Out-of-band SQL injection. Out-of-band SQL injection is used when the attacker cannot use the same channel to launch the attack and gather results, or when the server response is unstable. This technique relies on the database server making out-of-band requests, like HTTP or DNS, to send the query result to the attacker. HTTP is normally used in out-of-band SQL injection to send the query result to the attacker server. We'll discuss it in detail in this room later. So each type of SQL injection technique has its advantages and challenges. Understanding these techniques is crucial for identifying and mitigating SQL injection vulnerabilities in web applications. In-band SQL injection is easy to exploit and detect, but noisy and can be easily monitored. Inferential SQL injection is more challenging to exploit and require multiple requests but can be used when detailed error messages are unavailable. Out-of-band SQL injection is less common and highly effective, requires external server control, and relies on the database ability to make out-of-band requests. By mastering these techniques, penetration testers can effectively identify and exploit SQL injection vulnerabilities, helping organizations secure their applications against these critical threats. Answering the questions. What type of SQL injections uses the same communication channel for both injection and data retrieval? That's in-band. In out-of-band SQL injection, which protocol is usually used to send query results to the attacker server? HTTP. That second-order SQL injection. Second-order SQL injection which is also known as store SQL injection, exploits vulnerabilities where user supply input is saved and subsequently used in a different part of the application, possibly after some initial processing. This type of attack is more insidious because the malicious SQL code does not need to immediately result in an SQL syntax error or other obvious issues, making it harder to detect with standard input validation techniques. The injection occurs upon the second use of the data when it is retrieved and used in an SQL command, hence the name second order. The impact. The danger of the second-order SQL injection lies in its ability to bypass typical front-end defenses like basic input validation or sanitization, which only occur at the point of initial data entry. Since the payload does not cause disruption during the first step, it can be overlooked until it's too late, making the attack particularly stealthy. Example: we'll be using a book review application. The application allows user to add new book by the web page. Okay, let's try that. Users are prompted to provide details about the book they wish to add to the database. You can access the page on this URL right here. Copy and paste. Nope. The data collected included SSN, the book name, and the author. Let's consider adding the book right here. Intro to PHP. The name is Tim. Okay, so looks like this one has already existed in the database. So let's try another one. 1, 2, 3. Book name Intro to PHP, and author name is Tim. Okay, we have successfully added the book to the database. As we know, second-order SQL injection is notably challenging to identify. Unlike traditional SQL injection, which exploit real-time processing vulnerabilities, it occurs when data previously stored in a database is later used in a SQL query. Detecting this vulnerability often requires understanding how data flows through the application and is reused, necessitating a deep knowledge of the backend operation. We're going to take a look at the backend code right here. Consider the PHP code snippet used in the application. The code uses the real escape string method to escape the special characteristic of the input, which is right here. Okay. While this method can mitigate some risk of immediate SQL injection by escaping single quotes and other SQL meta characters, it does not secure the application against second-order SQLI or SQL injection. The key issue here is the lack of parameterized queries, which is essential for preventing SQL injection attacks. When data is inserted into the real escape string method, which is this one, okay. It might include payload characters that don't cause immediate harm but can be activated upon subsequent retrieval and used in another SQL query. For example, inserting a book with a name like intro PHP drop the table might not affect an insert operation, but could have serious implications if the book name is later used in another SQL context without properly handling. So let's try this one. Test. Hello world. Here we go. The SSN test is successfully added right here, as you can see in the database. The SSN test with a single quotation mark is successfully inserted into the table or database. The application includes a feature to update book details through an interface like the update.php. So let's go to the page. Okay, so we have 3 books right here. This interface might display existing books details in editable form fields, retrieved based on the earlier stored data, and then update them based on the user input. The pentester would investigate whether the application reuses the data, such as the book name, that was previously stored and potentially tainted. Then he would construct SQL queries for updating records using this potentially tainted data without proper sanitization or parameterization. By manipulating the update feature, the tester can see if the malicious payload added during the insertion phase gets executed during the update operation. If the application fails to employ proper security practices at this stage, the earlier injected payload, which is this one, could be activated, leading to the execution of a harmful SQL injection like dropping the table. Okay, we're on this page right here, the update page. Now let's review the update code. The PHP scripts allow users to update book details within the bookstore database through the query structure. We'll analyze a typical scenario where the penetration tester might look for SQL injection vulnerabilities, specifically focusing on how user inputs are handled and utilize SQL queries. So the script begins by checking if the request method is post and if the update button was pressed, indicating that a user intends to update the book in the book's details. Following this, the script retrieves the user inputs directly from the post data. So where is it? Okay, so this is the check right here. If there's a post request with the update button. Okay. Following this, the script retrieves user information directly from the post data. So SSN is equal right here. Okay, this is retrieving the information by retrieving the user input from the SSN field. Oh no, right here. Yeah. The new book is going to be, the new book name is going to be this one. So basically whatever we input right here, whatever we input right here, test hello, or let's say hero 1 or world 1 right here, is going to be inserted into this. This one is going to be the test with a single quotation mark. This one, the new book name, is going to be hello 1, and then this new author is going to be updated to world 2. Okay, these variables SSN, new book name, and new author, then used to construct SQL query for updating the specified book's detail in the database. Alright, so once these variables are set, they will be used in a single SQL command right here. Update the books, set the book name equals to the new book name. In this case is hello 1, and the author name is world 2. The script uses multi-query to execute multiple queries. It also inserts log into the logs table for analytical purposes. Preparing the payload. We know that we can add or modify the book details based on the SSN. The normal query for updating a book might look like this. Update books, set the book name. Okay, this is a regular update SQL command statement. However, the SQL command could be manipulated if the attacker inserts a specially crafted SSN value. So let's try that. This is going to be the payload right here. Copy. We add a book 1, 2, 3, 4, 5, and then 1. Okay, it's been added. It's right here. When this value is used in the updated query, it effectively ends the initial update command after the 1, 2, 3, 4 and starts a new command, which is updating the order books here. Order books name to hacked. So let's say we try to edit the author name right here, something else, and then once we click update, all the book names are changed to hacked. Let's try that. There we go. New book name hacked right here. We actually can confirm from this page too. See, all the book names have been changed to hacked. Alright, so this is how we perform initial payload right here. So we've done it. Malicious SQL execution. After that, we add it. Okay, we are several steps ahead. Okay, don't worry about it. So after that, when any other user visit the page, this one, and updates the book. The insert payload breaks out the intended SQL command structure and injects a new command that updates all the record of the books table. So that's exactly what happened right here. Commenting out the rest. So you notice at the end we have these two dashes right here. The double dash is an SQL comment symbol. Anything followed by these two dashes will be ignored by the SQL server, effectively neutralizing any remaining parts of the original SQL statement that could cause errors or reveal the attack. Once the book query is executed, you change all the name of all the books to hacked. Okay. Alright, so using the same concept, let's try to get the flags. What is the name of the flag while you updating the titles to compromise? So first we have to add the book, which is this one, the payload. Change name to compromise. Now these aren't important. Refresh the page. We see this newly added book right here. We have a compromise. So once I update whatever it is, well, it doesn't have. So one thing to keep in mind, it doesn't have to be. You don't have to update this book. You can update any other books. So team, whatever right here. Once you click update, oh, that's weird. Oh yeah, sorry, my bad. You have to update this specific book with a special payload right here, because this record contains the malicious payload, so you have to update this one. My bad. Sorry guys, just woke up. And now all the books have been changed to compromise. And we got the first flag. What is the value once you drop the table hello from the database? Alright, let's try that. Hello. Table dropped. Okay, moving on next. Filter evasion techniques. In advanced SQL injection attacks, evading filters is crucial for successfully exploiting vulnerabilities. Modern web applications often implement defensive measures to sanitize or block common attack patterns, making simple SQL injection attempts ineffective. As pen testers, we must adapt using more sophisticated techniques to bypass these filters. This section will cover such methods, including character encoding, no-code SQL injection, and handling scenarios where spaces cannot be used. We can effectively penetrate web applications with stringent input validation and security controls by understanding and applying these techniques. Character encoding. Character encoding involves converting special characters into the SQL injection payload into encoded forms that may bypass input filters. URL encoding. We have several types of encoding. We have URL encoding, we have hexadecimal encoding, and then Unicode encoding. URL encoding is a common method where characters are represented using a percent sign followed by their ASCII value in hexadecimal. For example, the payload single quote or 1 equals 1 double dash can be encoded as this string right here. You can easily obtain this by using the Shabashab. So URL encode. You can see everything is the same right here. Oh, we have to encode on special characters. Now, if you notice right here, CyberChef also encode the double dash right here, whereas in over here it doesn't encode the um, whereas over here it doesn't encode these two dashes. Sometimes depending on the application, you can just ignore these two, or sometimes you have to encode them. For me, I would prefer encoding all of them. Like, why not? They're going to be decoded by the SQL server anyway. So this encoding can help the input pass through the application filters and be decoded by the database, which might not recognize it as malicious during initial processing. Hexadecimal encoding. Hexadecimal encoding is another effective technique for constructing SQL queries using hexadecimal values. For instance, the query select everything from users where name equals name, where name equals admin, can be encoded as select everything from users where name equals to these hexadecimal values. Okay, we can easily obtain this using CyberChef to hex right here, and we see its spaces right here, right? Delimiter, none, and we get the same values right here. By representing characters as hexadecimal numbers, the attacker can bypass filters that do not decode these values before processing the input. Similar concepts, different kinds of encoding. Unicoding. Unicoding encodes represents a character using Unicode escape sequences. For example, the string admin can be decoded as this string right here. This method can bypass filters that only checks for specific ASCII characters, as the database will correctly process the encoded input. The same thing, you can achieve the decoded no you can achieve the encoded string using the CyberChef. Example. In this example, we explore how developers can implement basic filtering to prevent SQL injection attacks by removing specific keywords and characters from the user input. However, we also see how attackers bypass these defenses using character encoding techniques like URL encoding. Note, in the upcoming exercises, we use a database that are different from the last one. You can access the page right here. Okay. Here's the code. Okay, we have an array of special characters or an union select. We have a book name string replaced. Okay, here's a JavaScript code in the index HTML page that provides the user interface for the search book. Alright, so this is the search book. Now, even though it doesn't require you to learn how to code, it is also it's beneficial to you to actually read the code, to be able to read the code and understand what the code does, because sometimes you may be required to perform a code review, and then by doing the code review you spot these vulnerabilities by doing static code analysis. Now here we can see the vulnerabilities is right here, the issues right here. It performs a SQL injection. Not SQL injection. It performs an SQL query without parameterize it, meaning that wherever, if we have a malicious input right here, it will escape the string right here and actually alter the behavior of and actually modify the query, which alter the behavior of the application. We'll see it later. Let's continue reading. Okay, let's start again. Example. In this example, we explore how developers can implement basic filtering to prevent SQL injection by removing specific keywords and characters from the user input. However, We'll also see how attackers can bypass these defenses using character encoding techniques like URL encoding. Note, in the upcoming exercises, we'll use databases that are different from the last ones. You can access the page right here, which I've already done. So here's a code that handles the search functionality. And here's the JavaScript code for the index HTML, which is right here. Okay, so in this code, we see there's a special characters array which contains all the uppercase, lowercase, and uppercase, lowercase, union, and select. So what I would infer from this code is that the application will look for any of these special characters and will strip or blacklist these characters. That's my guess. Let's continue. In the above example, the developer has implemented a basic defense mechanism to prevent SQL injection attacks by removing the specific SQL keywords, such as or, and, union, and select. The filtering uses the string replace function, which strips these keywords from the user input before they are included in the SQL query. This filtering approach aims to make it harder for attackers to inject malicious SQL commands, as these keywords are essential for many SQL injection payloads. Preparing for the payload. Let's go through the process of preparing an SQL injection payload step by step, showing how URL encoding can bypass basic defenses. First, let's see what happens with a normal input that contains special characters to all SQL keywords. When we search for the book name Intro to PHP, we get successful results. Alright. But what if we try to break the query by adding special characters? Let's try that. Single quotation mark. We've got an error. The SQL query is not executing correctly, which probably means there is a chance of SQL injection. Let's try to inject the payload into PHP or 1 equals 1. Copy, paste. We shouldn't see the or. Yes. Select everything from books where book names equals to string. No, intro PHP. And then we see right here, the or is replaced by the space. So what's happening here? When this input is passed to the PHP script, the string replace function will strip the or keyword and the single quotation mark. Resulting in a sanitized input that will not execute the intended SQL injection. This input is ineffective because the filtering removes the critical components needed for the SQL injection to succeed. To bypass the filtering, we need to encode the input using the URL encoding, which represents special characters and keywords in a way that filters does not recognize and remove. Here's the example. Okay, we can try this one. Now, if you don't know what this is, we can try it over here and URL decode. First, remove this one. Alright. So this is what it will look like. Percentage 27 is the URL encoding for the single quotation mark. Okay. This represents a space, and this is the or, represent or's operator. This one it represents the equal signs, and these two represent double dashes. In the above payload, one with the single quotation mark closes the current string or value in the SQL query. For example, if the query is looking for a book name that matches 1, adding this quotation mark closes the string, making the rest of the input part of the SQL statement or 1 equal 1 part uses the SQL or operator to add a condition that is always true. This part uses the SQL or operator to add a condition that's always true. This condition ensures that the query returns true for all records, bypassing the original condition that was supposed to restrict the results. Similarly, these two dashes starts a command in SQL causing the database to ignore the rest of the query. This is useful to terminate any remaining part of the query that might cause syntax errors or unwanted conditions. Now, at this point, we don't have to go deep into the explanations of these, special characters. The common characters or equal signs, we're already familiar with that, so we skip it. To ensure proper spacing, a plus sign added add a space after comment, ensuring that the comment is properly terminated and there are no syntax issues. From the console, we can see. Okay, let's try that first. Let's see what happens. No. Wait, let's see what happens first. This one. Okay. So we can see in this case, in this specific example, we don't necessarily have to perform a URL encoding. We can just like replace the OR operator with these two, and it should do the job. We get all the records of the book right here. But for the purpose of demonstration, let's go through the approach where we use the URL encoder. So we inspect the console, open the console, inspect the network tab right here. Let's try performing a search intro to PHP. Search. We see there's an Ajax call right here. Let's take a look at it. Now this is a little bit hard to see, so bear with me for a second. If you hover this request, we see the whole URL http 10.10.30.217/encoding/search book php. The book name is equal to intro and %20 to %20 php. Now, if you forget, %20 represents a space. So after using URL decoding, we get the human readable string right there at the bottom. Book name equals to intro to PHP. Now we can try the payload right here. So this is going to be the payload that we are going to about to do it. Let's try that. Okay, let's see. I did something wrong. The book name equals 1. Okay, it doesn't work. Well, this one will definitely give an error because there's an OR right here. So we replace this with this one. How come this one doesn't work? The name. everything looks the same. Let's see. Select where the book name equals 1. Oh, okay, so I guess we don't put it here. We have to put it into the URL. Okay, hold on a second. Okay, I got it. Intro to PHP. So this is the full URL path in code search box. There we go. Now we can replace the name with this payload right here. No. Oh yeah. And we got the list of the book. Right, the payload works because the URL encoding represents special characters and SQL keywords in a way that bypasses the filter mechanism. When the server decodes the URL encoded input, it restores the special characters and keywords, allowing the SQL injection to execute successfully. Using URL encoding, attackers can craft payloads that bypass basic input filtering mechanisms designed to block SQL injection. This demonstrates the importance of using the most robust defenses, such as parameterized query and prepare statement, which can prevent SQL injection attacks regardless of user input coding. What is the MySQL error code for invalid query when entering with bad characters? What's the error? Error? What? No. What is the MySQL error code once a invalid is entered with the bad characters? Oh, right here. Brr. What is the name of the book where the book ID is 6? Book ID is 6. Animal series. Right. The next filter evasion techniques, no-code SQL injection. No-code SQL injection techniques are used when the application filters single quotes or double quotation or escapes. Using numerical values. One approach is to use numerical values or other data types that do not require quotes. For example, instead of injecting single quotation mark or 1 equals 1, an attacker can use or 1 equals 1 in a context where the quotes are not necessary. This technique can bypass filters that specifically look for an escape or strip out quotes, allowing the injection to proceed. Using SQL commands. Another method involves using SQL commands to terminate the rest of the SQL query. For instance, the input admin can be transformed into the admin dash where the dash signifies the start of a command in SQL, effectively ignoring the remaining of the SQL statement. This can help bypass filters and prevent syntax error using the concat function. Attackers can use SQL functions like concat to construct strings without code. For example, concat, this is hexadecimal value, and these are going to be the admin. Construct the string admin, yes. The concat function and similar methods allow attacker to build string without directly using the code, making it harder for filters to detect and block the payload. No space allowed. When spaces are not allowed or are filtered out, various techniques can be used to bypass the restrictions. Commands to replace the spaces. One common method is to use SQL commands. So this is used for block commands, whereas the double dash is only used for a single line command. For example, instead of select everything from user where name equals admin, attackers can use select and then these two form username. This is an escape character. Select everything from user where name equals admin. SQL commands can replace spaces in the query, allowing the payload to bypass filters that remove or block spaces. Tab on new line characters. Same concept. Instead of using the commands, we can use the new line. We can use a tab. We can also alternate the characters. So there are several ways to replace the space with the commands, the new lines, the tab, select, tab, form, tab, users, tab, where, tab, name, tab, equals, tab, admin. This technique can bypass filters that specifically look for spaces. Alternate characters. One effective method is using the alternate URL encoded characters representing different types of white spaces, such as the horizontal, okay, line feed, from feed, carriage return, and non-breaking space. These characters can replace spaces in the payload. Alright, let's try that. In this scenario, we have an endpoint. Search user. Excuse me. That returns user details based on the provided username. The developer has implemented filters to block common SQL injection keywords such as or, and spaces to protect against SQL injection attacks. Here's a PHP filtering. Okay. Again, right now you may not be required to understand what this is, but in the future you may be required to do a code review where you do perform a code analysis and you spot the vulnerabilities in the code. So it's very useful to actually know, at least you don't have to know exactly how to build it, but know what the code does is really helpful for you. Here's a PHP filtering added by the developers. If we use our standard payload on the endpoint, we can see that it's not working. Let's try that. No? Yeah, fine. Okay. Form. Okay. So we can see it's not working. You have error in your SQL syntax. Check the menu. Okay. It's not working. The SQL query shows that the spaces are being omitted by the code. Yeah, right here, all the spaces are omitted. To bypass these protections, we can use zero encoded characters that represent different types of the white space on line breaks, like this one or this one, horizontal tab, line feed. These characters can replace spaces and still be interpreted correctly by the SQL parser. So we have the original. Let's try that. Original payload is right here, or 1 = 1. Now because we don't have the spaces are not allowed. Okay, first of all is blacklisted, so we have to replace this one with this and one. We can use a line feed. Okay, let's use it. Line feed is 008. Okay, 008, 1 = 1, 008 dash 027 plus. Let's encode everything. I like to encode everything. Wait, let's double check one more time. No. My bad. Okay, you know what? 1 = 1. We encode everything and we replace this 020. We replace %20 with %08. To be. Okay, looks good. Let's try that. This payload construct the same logical as. No, it doesn't. Wait, what did it do wrong? Alright, so I guess there was something wrong with my query, with my payload when I was preparing that. So yeah, this is the payload we use, and we got all the users in our database. This payload constructs the same logical as a condition, but uses new line characters to bypass the space filter. The SQL parser interprets the new line characters as spaces, transforming the payload into 1 = 1. Therefore, the query will be interpreted from. Okay, so we get to the basic regular SQL query. Alright, to summarize, it is important to understand that no single technique guarantees a bypass when dealing with filters or web application firewalls designed to prevent SQL injection attacks. However, here are some tips and tricks that can be used to circumvent these protections. This table highlights various techniques can be used to employ to try and bypass filters and the WAF. The keywords like select a band, we can use uppercase, lowercase keywords. SQL keywords can often be bypassed by changing their case and adding inline comments to break them up. Okay, we can use uppercase, lowercase right here, or using the comment to separate them. Spaces band, we talk about that. We use special line feeds or horizontal tabs or any other special characters using alternate white spaces characters or comments to replace spaces. Logical operator and or band. Again, the same thing. Using alternate logical operators or concatenation but to bypass. We have this or we have this. Common keywords like union select a band. Using equivalent representations such as hexadecimal or Unicode encoding. Okay. Specific keywords like or and select union a band. Using obfuscation technique like to disguise SQL keywords by combining characters with string functions or comments. Okay, right. Using the concat function. In real environments, the queries you apply and the visibility of the future keywords are not directly possible. As a pen tester, it is important to understand that SQL injection testing often involves a hit and try approach, requiring patience and perseverance. Each environment can have unique features and protections, making it necessary to adapt and try different techniques to find successful injection vector. What is the password username attacker? Tesla. Which of the following can be used if the select keywords is banned? Yeah, we can use no. Yeah, we can use this one. See. Right, let's talk about out-of-band SQL injection. Out-of-band SQL injection is an attack technique that pen tester or red teamer use to exfiltrate data or execute. Out-of-band SQL injection (OOB SQL injection) is an attack technique that pen tester or red teamer use to exfiltrate. Out-of-band SQL injection. Out-of-band or OOB SQL injection is an attack technique that pen tester or red teamer use to exfiltrate data or execute malicious actions when direct or traditional methods are ineffective. Unlike in-band SQL injection, where attacker relies on the same channel for attack and data retrieval, out-of-band SQL injection utilizes separate channels for sending the payload and receiving the response. Out-of-band techniques leverage features like HTTPS requests, DNS queries, SMB protocols, and other network protocols that the database server may have access to, enabling attackers to circumvent firewalls, intrusion detection systems, and other security measures. One of the key advantages of out-of-band SQL injection is its stealth and reliability. By using different communication channels, attackers can minimize the risk of detection and maintain a persistent connection with the compromised system. For example, an attacker might inject a SQL payload that triggers the database server to make a DNS request to a malicious domain controlled by the attacker. The response can then be used to extract sensitive data without alerting security mechanisms that monitor direct database interactions. This method allows attackers to exploit vulnerabilities even in a complex network environments where direct connectivity between the attacker and the target is limited or scrutinized. So why do we use OOB? In scenarios where direct responses are sanitized or limited by the security measures, OOB channels enable attackers to exfiltrate data without immediate feedback from the server. For instance, security mechanisms like store procedures, output encoding, and application-level constraints can prevent direct responses, making traditional SQL injection attacks ineffective. Out-of-band techniques such as using DNS or HTTP requests, allow data to be sent to an external server controlled by the attacker, circumventing the restrictions. Additionally, intrusion detection system (IDS) and the web application firewalls (WAPs) often monitor and log SQL query responses for suspicious activity, blocking direct responses from potentially malicious queries. By leveraging OOB channels, attackers can avoid detection by using less scrutinized network protocols like DNS or SMB to transfer data. This is particularly useful in network environments with limited direct connectivity between the attacker and the database server, such as when the server is behind the firewall or in a different network segment. Techniques in different databases. Out-of-band SQL injection attacks utilize methodologies operating to another communication channel through a crafted query. This technique is effective for exfiltrating data or performing malicious actions when direct interaction with the database is restricted. There are multiple commands within there are multiple commands within the database that may allow exfiltration, but below is a list of the most commonly used in various database systems. MySQL and MariaDB. Um, so in these two databases, we can use select into our file or the load file command. This command allows an attacker to write the results to a query on a file on the server file system. An attacker could then access the file via SMB share or HTTP server running on a database server, thereby exfiltrating the data through the alternate channel. Microsoft SQL Server. In Microsoft SQL Server, out-of-band SQL injection can be performed using features like the XP command shell, which allows the execution of the shell commands directly from the SQL queries. This can be leveraged to write data to a file accessible via network share. Alternatively, open row set or bulk inserts can be used to interact with external data sources, facilitating data exfiltration through the OOB channels. Oracle. In Oracle databases, out-of-band SQL injection can be executed using the util HTTP or util file packages. For instance, the util HTTP package can be used to send the HTTP request with sensitive data. And this is the code. Examples of the out-of-band techniques. Out-of-band SQL injection techniques in MySQL and MariaDB can utilize various network protocols to exfiltrate data. The primary methods of including DNS exfiltration, HTTP requests, and SMB shares. Each of these techniques can be applied depending on the capability of the MySQL or MariaDB environments. HTTP requests. By leveraging database functions that allow HTTP requests, attackers can send sensitive information directly to a server they control. This method exploits database functionalities that can make outbound HTTP connections. Although MySQL and MariaDB do not natively support HTTP requests, this can be done through external script or user-defined function (UDFs) if the database is configured to allow such operations. First, the UDF needs to be created and installed on the supported HTTP request. The setup is complex and usually involves additional configuration. An example query should look like select HTTP post and then with the server to the attacker with from bugs. First, the UDF needs to be created and installed to support the HTTP request. This setup is complex and usually involves additional configuration. An example query looks like this. Select HTTP post, which is a post request, and this one is going to be the attacker server. This is going to be the sensitive data from the database, and this is the table names. HTTP request exfiltration can be implemented on Windows and Linux, depending on the database support for external script or UDFs that enable HTTP requests. DNS exfiltration. Attackers can use SQL queries to generate DNS query with encoded data, which is sent to the malicious DNS server controlled by the attacker. This technique bypasses HTTP DNS exfiltration. Attackers can use the SQL query to generate a DNS request. My God, what the? SMB exfiltration. SMB exfiltration involves writing query results to an SMB share on an external server. This technique is particularly effective in Windows environments, but can also be configured in Linux systems with the right setup. An example query should look like: select sensitive data into a file, and then this is going to be the SMB share. This is fully supported as Windows natively support SMB UNC paths. Linux, while direct UNC paths are more native to Windows, SMB shares can be mounted and accessed in Linux using tools like SMB client, or by mounting the share to a local directory. Directly, using a UNC path in SQL queries may require additional setup or scripts to facilitate the interaction. Practical example. In this practical scenario, we will demonstrate how an attacker can exfiltrate data from a vulnerable web application using out-of-band SQL. Out-of-band SQL injection technique. The server-side code contains an SQL injection vulnerability that allows attacker to grab a payload that writes the result to a query to an external SMB share. This is useful when direct responses from the database are restricted or monitored. Scenario explanation. In this scenario, we would enable a network share on the attacker box at this directory. This share is accessible over the network and allows files from other machines to be written on. You may assume a scenario where you get a vulnerable system and want to pivot data to another network share system. The attacker will leverage this share to exfiltrate data out of band. To have a network share, start the attack box. Okay. Execute the following command. Navigate to in package. Examples: Python 3.9 SMB server. So this one actually set up the SMB server on Linux. Alright, let's open a new terminal. You can access the contents of the network share by entering the following one. Let's try that. SMB client 10.10.194.122 logs. SMB client. Okay, we can run the ls command to see everything. Let's enlarge the screen. So hopefully the output is more clear. So let's see what do we have. We have these are the files. Okay, nothing much. So basically we have successfully set up the SMB. So what's next? We have the same web application with a search feature that queries visitors who visit the library. The server-side code for this feature is vulnerable to SQL injection. You can access it through this one. Let's try it. And this is the server code. And make sure I just copy this URL. Okay. Important consideration. It is important to note that MySQL system variable secure file brief may be set. When set, this variable contains a directory path name, and MySQL will only allow files to be written to the specified directory. This security measure helps mitigate the risk of unauthorized file operations. When secure file brief is set, MySQL will restrict file operations such as into our file to the specified directory. It means that attackers can only write files to this directory, limiting their ability to exfiltrate data to arbitrary location. When secure file is empty, MySQL does not impose any directory restrictions, allowing files to be written to any directory accessible by the SQL Server process. This configuration poses a high risk as it provides more flexibility for attackers. Attackers typically do not have direct access to check the value of the secure file brief variable. As a result, they must rely on hit and trial methods to determine if and where they can write the files, testing various paths to see if the file operations succeed. Now let's prepare the payload. To exploit this vulnerability, the attacker crafted a payload to inject into the visitor name. So this is going to be the point of injection. Let's take a look at this. So this actually shows the versions of the database used by the application. What is 10.10, 184, 122. Ten dot 10, 194, 122. Okay. So let's dissect the above payload. This one is the closest to the original string with its SQL query and the first SQL statement. Select the version into file, and this one is to execute the SQL command to provide the database versions output into the file, and then call the out.txt and send it to the SMB share right here. To utilize the payload, the attacker would visit the URL and create a file in the external SMB file. To access the file, use the ls 10 folder to the file receive to see the file received. To access the file, use ls tmp to see the file received in the tmp directory. Okay. So we have the payload ready. Okay, we have some changes over here. All right, so we see this one. Oh, okay, so this is the database version 10.4.24 MariaDB. I think there's a flag, right? Yeah. What is the value of the base dirt variable? Okay, so now base dirt, base dirt. Alright, so these are only the few commands SQL queries that we can run on the target machine. This is a proof of concept. We can actually use the same approach to run any commands that we want to on the target machine to extract information from the database and then enumerate database tables and columns. Now let's move on to the next one, other techniques. Advanced SQL injection involves a range of sophisticated methods that go beyond basic attacks. Here are a few important advanced techniques that PenTesters should be aware of. HTTP header injection. HTTP headers can carry user input, which might be used in SQL queries on the server side. If these inputs are not sanitized, it can lead to SQL injection. The technique involves manipulating HTTP header, like the user agent, referrer, or Exfiltrating to inject SQL commands. The servers might lock these headers or use them in SQL queries. For example, a malicious user agent header would look like user agent single quote or 1 equals 1. If the server includes the user agent header in an SQL query without sanitizing it, it can result in SQL injection. In this example, a web application logs the user agent header from HTTP request into a table named logs in the database. The application provides an endpoint at this one, HTTP, that displays all the logs entry from the logs table. When users visit the web page, the browser sends a user agent header, which identifies the browser operating system. This header is typically used for logging purposes or to tailor content for specific browsers. In our application, this user agent header is inserted into the logs table and can be then viewed through the provided endpoint. Given the endpoint, an attacker might attempt to inject SQL code into the user agent header to exploit SQL injection vulnerabilities. For instance, by setting the user agent header to malicious values such as union select username password from user, an attacker attempts to inject SQL code that combines the results from the logs table with sensitive information from the user table. And here's the code to insert the logs. The user agent value is inserted into the logs table using the insert SQL statement. If the insertion is successful, a success message is displayed. An error message with details is shown if there's an error during the insertion. Now let's prepare the payload. We'll prepare this payload and inject an SQL into We'll prepare and inject an SQL payload into the user agent headers, demonstrating how SQL injection can be exploited through the HTTP headers. Our payload will be union select username password from user. This payload is designed to close the existing string literal. Alright, so this is going to be the payload. we need to send these payloads as a part of user agent header HTTP request. We can use burp with, or we can simply use the curl command line. Either one's fine. So let's use curl user agent. This is the endpoint. Okay, we have the header. Let's run it. Do we see anything? Okay, it looks like there's something showing up. Let's try this. Okay, so we have ID Bob user agent Bob123, ID attack user agent Tesla. Select everything from logs where user agent equals. You select username, password from user. The server's response will be displayed in the terminal. If the SQL injection is successful, you see the extracted data, username, and password in the response. Okay. So yeah, it shows right here in the terminal, and then it's a little bit hard to read, so that's why I put it in an HTML file and then view that in the browser, which is easier. Store procedures are routine store procedures are routine store in database that can perform various operations such as inserting, updating, and query data. While store procedures can help improve performance and ensure consistencies, they can also be vulnerable to SQL injection if not properly handled. Store procedures are precompiled SQL statements. Store procedures are precompiled SQL statements that can be executed as a single unit. They are stored in a database and can be called by applications to perform specific tasks. Store procedures can accept parameters, which can make them flexible and powerful. However, if these parameters are not properly sanitized, they can introduce SQL injection vulnerabilities. And this is an example of the store procedures. Create the procedures. Okay. In this example, the store procedures concatenates the username parameter into a dynamic SQL query. This approach is vulnerable to SQL injection because the input is not sanitized. Right here. XML and JSON injection. Applications that parse XML or JSON data and use the parse data into SQL queries can be vulnerable to injection if they do not properly sanitize the inputs. XML and JSON injection involves injecting malicious data into the XML or JSON structures that are then used in SQL queries. This can occur in the application directly uses parsed value into SQL statement. If the application uses the values directly in the SQL query line, select everything from users where username equal admin or 1 equal 1's password, it could result in an injection. So this can lead to this SQL query right here, which is a result of an injection. What is the value flag field in the book? Answer the question. What is the value of the flag field in the books table where book ID equals 1? Okay, I think we can use the user agent. Let's modify the payload. Union select books where book ID equals 1. What is the flag field? Select flag. The other one we don't care, so we just no. Copy this one. Curl http 10.10.242.230 http agent. Hmm. 230, not 240. New log insert successful. Select everything from where user right here. Okay, so this one didn't. Okay, there's something wrong. I didn't see. There's something wrong. This one should be correct. So we got a user agent right here. Let's try again. We don't see anything. That's weird. Oh my god. I forgot to specify the header. My bad. Okay, we got a flag right here. This one right here. TryHackMe hello. This is a flag. Okay, let's try the command. This command one more time to see the users. Hmm? Yeah. So this one is correct. Alright, so this one, the command, I forgot to specify the user agent, which is why it didn't show anything. But after I add this one, it shows me the flag right here. Hello, TryHackMe hello. That was the flag. TryHackMe. What field is detected on the server side when extracting the user agent? User agent? Yep. Right, automation. SQL injection remains a common threat due to improper implementations of security measures and the complexity of different web frameworks. Automating identification and exploiting these vulnerabilities can be challenging, but several tools and techniques have been developed to help streamline this process. The major issue during the identification. Identifying SQL injection vulnerabilities involves several challenges, similar to identifying any other server-side vulnerability. These are the few key issues. Dynamic nature of SQL queries. SQL queries can be dynamically constructed, making it difficult to detect injection endpoints. Complex query with multiple layers of logic can obscure potential vulnerabilities. Variety of injection points. SQL injection can occur in different parts of the application, including input fields, HTTP headers, and URL parameters. Identifying all potential injection points requires thorough testing and a comprehensive understanding of the application. The use of security measures. Applications can use a prepare statement, parameterized query, and ORM frameworks, which can prevent SQL injection. Automatic tool must be able to differentiate between the safe and unsafe query constructions. Context-specific detection. The context in which user inputs are used in SQL queries can vary widely. Tools must adapt to different contexts to accurately identify vulnerabilities. There are a few tools that we can refer to: SQL Map, SQL Ninja, SQL Injection, and BBQ SQL. Wow. So SQL Map is an open source tool that automates the process of detecting and exploiting SQL injection vulnerabilities in web applications. It supports a wide range of databases and provides extensive options for both identification and exploitation. SQL Ninja is a tool specifically designed to exploit SQL injection vulnerabilities in web applications that uses Microsoft SQL Server. Okay, so this one is specifically designed for Microsoft SQL Server. How about this one? JSQL is designed for Java library. Okay, so this is mainly for Java application. BBQ SQL is a blind SQL injection exploitation framework designed to be simple and highly effective for automated exploitation of blind SQL injections. Okay. Automating the identification and exploitation of SQL injection vulnerability is crucial for maintaining web application security. Tools like SQL Map, SQL Ninja, BBQ SQL provide powerful capabilities for detecting and exploiting these vulnerabilities. However, it's important to understand the limitations of automated tools and the need for manual analysis and validation to ensure comprehensive security coverage. By integrating these tools into your security workflow and following the best practices for input validation and query construction, you can effectively mitigate the risks associated with the SQL injection vulnerabilities. Does the dynamic nature of the SQL queries assist the PenTest in identifying? No. The best practice. SQL injection is a renowned and pervasive. SQL injection is a renowned and pervasive vulnerability that has been a major concern in web application security for years. Pentesters must pay attention to this vulnerability during the assessment, as it requires a thorough understanding of various techniques to identify and exploit SQL injections. Similarly, secure coders must prioritize safeguarding the application by implementing robust input validation, and adhere to secure coding practices to prevent such attacks. Here's a few things to keep in mind. Parameterized queries and prepare statements. Use parameterized queries and prepare statements to ensure all user inputs are treated as data rather than executed code. This technique helps prevent SQL injection by separating the query structure from the data. Input validation and sanitization. Implement strong input validation and sanitization to ensure that the inputs conform to expected formats. Validate data types, lengths, and ranges, and reject any input that does not meet these criteria. Use the built-in functions such as the HTML special characters and filter var to sanitize inputs effectively. The least privilege principle. Apply the principle of least privilege by granting applications account the minimum necessary database permission. Avoid using database accounts with administrative privileges for everyday operations. This minimizes the potential impact of successful SQL injection by limiting the attacker access to critical database. Store procedures. Encapsulate and validate SQL logic. Encapsulate and validate SQL logic using store procedure. This allows you to control and validate the input within the database itself, reducing the risk of SQL injection. Ensure that store procedures only accept validated input and are designed to handle input sanitization. Regular security audits and code review. This is a must. Conduct regular security audits and code review to identify and address vulnerabilities. Automated tools can help scan for SQL injection risk, but manual reviews are also essential to catch subtle issues. Regular audits ensure that your security practices stay up to date with evolving threats. PenTester, exploiting database-specific features. Different database management systems have unique features and syntax. A PenTester should understand the specific specific target of DBMS. PenTester, exploiting database specific pentesters, exploiting database specific features. Different database management systems have unique features like and syntax. A pentester should understand specific database target to exploit these features. Oh my god. Pentesters, exploiting database specific features. Different database management systems have unique features and syntax. A pentester should understand the specifics of target DBMS to exploit this feature effectively. For instance, MSSQ support the XP command shell command, which can be used to execute system commands. Leveraging error messages. Exploit verbose error messages to get insight into the database schema and structures. Error-based SQL injection involves provoking the application to generate errors that reveal useful information. For example, using this query 1 and 1 equal convert int can generate errors that leak version information. Bypassing WAF and filters. Test various obfuscation techniques to bypass the application firewalls. Pentesters, exploiting database-specific features. Different database management systems have unique features and syntax. A pentester should understand the specifics of the target DBMS to exploit this feature effectively. For instance, Microsoft SQL supports the XP command shell command, which can be used to execute system commands. Leveraging error messages. Exploit verbal error messages to get insight into the database schema and structures. Error-based SQL injection involves provoking the application to generate error messages that reveal useful information. Bypassing WAF and filters. Test various obfuscation techniques to bypass the web application firewalls and input filters. This includes using mixed case concatenation, alternate encoding, etc. Additionally, using inline commands and different characters encoding can help bypass simple features. Database fingerprint. Determine the type and the versions of the database to tailor the attack. This can be done by sending specific queries that yield different results depending on the DBMS. Pivoting with SQL injection. Use SQL injection to pivot and exploit other parts of the network. Once a database server is compromised, it can be used to gain access to other internal systems. This might involve extracting credentials or exploiting trust relationships between the systems. Advanced SQL injection testing requires a deep understanding of various techniques and the ability to adapt to different environments. Pentesters should employ various methods, from exploiting database-specific features to bypassing sophisticated features to thoroughly accessing and exploiting SQL injection vulnerabilities, methodically documenting each step to ensure that a comprehensive evaluation of the application is ensures a comprehensive evaluation of the application's security. So what command is my MSSQL support? So what command does MSSQL support execute system command? Is XP command shell. Whoa. CMD shell. XP CMD shell. Submit. Alright, so that's it for the room today. We have gone over a few techniques to bypass filter Alright, so that's it for the room today. We've gone over second order SQL injection, out-of-band SQL injection, some of the techniques to bypass web application filters, and some of the automation tools. We also learn about some mitigation measures when it comes to SQL injections, how to perform a thorough penetration testing as a pen tester, and how to write secure code as a developer. I hope. Okay, conclusion. Alright, so we have explored advanced SQL injection techniques, including second order SQL injection and out-of-band SQL injection. We also learned about some technique. Okay, so that's it for the room today. We have successfully talked. Okay, so that's it for the room today. We have explored second order SQL injection, out-of-band SQL injection, as well as some filter evasion techniques. We also learned about some mitigation security measures. Alright guys, so that's it for the room today. We have explored second order SQL injection, out-of-band SQL injections, filter evasion techniques, automation tools, and some mitigation measures and some security measures for SQL injection vulnerabilities. We also learned the best practices when it comes to coding a web application and what to do as a pen tester to perform a thorough penetration testing of applications. Alright, if you have any questions, please let me know. I know this room is a little bit advanced or medium for a lot of people. I know this room is a little bit advanced for some people. So if you have any questions or something that a little bit confusing to you, please reach out to me. Feel free to reach out to me. I'll be happy to help. Alright, so that's it for the room today. We have explored second order SQL injection, out-of-band SQL injection, some filter evasion techniques, automation tools, and some security best practices when it comes to preventing SQL injections. When it comes to SQL injection, I hope you enjoy this room. I know it's a little bit advanced for some of you guys, so if you have any questions, feel free to reach out to me. I'll be happy to help. Alright, until next time, see you, bye.